Welcome to Mbose Educator. Mathematics Class 10, New Book, Chapter 2 Polynomials, Exercise 2.2, Question number 1, Part number 1 to 6. This is Exercise 2.2. In this exercise, we have two problems to solve, problem number 1 and problem number 2. In this video, today we shall solve problem number 1. And we have 6 parts in problem number 1. Part number 1, 2, 3, 4, 5, 6. Let's start. This is question number 1. The question is, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Let's understand the question first. These are some quadratic polynomials and we have to find the zeros of quadratic polynomials. And then we have to verify the relationship between the zeros which we shall find out and the coefficients of the variables given here. That means x square and x. Alright. So let's solve first part number 1. Then we can understand easily. The part number 1 is x square minus 2x minus 8. X square minus 2x minus 8 equals 0, because we have to make it equation first. Earlier it was expression, now it is equation, because we have to find out the value of zeros. That's why 0 we have to put here. Alright. Now this problem we can solve by a popular method, that is splitting up the middle terms. We have to split up this middle terms, means 2x, in this way that the sum or difference will be 2x and the product of these two terms must be 8. In that way we can do one thing. We have to split up. We can take 8 first and we can find the prime factors of 8. That means 2. 2 4s are 8. Now we can check here. This 2 product we got here. If we shall multiply, it will be 8. And if we shall subtract, that means 2 into 4, it is 8. And 4 minus 2 equal this 2 equal to minus middle term. All right, we can write here now x square as it is minus, in the place of 2 we can write 4 minus 2, because we have to split up the middle term, and x will be as it is minus 8 equal 0. All right, now we shall calculate x square will be as it is minus this minus 4 into x will be minus 4x, minus into minus will be plus, 2 into x will be 2x, minus 8 equal 0. Now you can see minus 4x and plus 2x, it means equal to minus 2x. All right, now these 3 terms become 4 terms, and we can make these 4 terms into 2 parts, equally 2 parts. That is this 2 in one part and this 2 is another part, altogether 2 parts. All right. Now in first part, which factor is common? That is x. X is common in both the term. So we can write here, we can take common x. Now x square we can divide by x, answer will be x, minus 4x we can divide by x, then x cancel, it will be 4. Alright. Plus in second part, which element will be common here? That is 2. 2 is common in both the term, in 2x also, in 8 also. So 2 we can take common. Then if you shall divide 2x by 2, 2 cancels 2, answer will be x, minus by 8 we can divide 2, it will be 4 equals 0. Here one important thing you have to remember, that is the two brackets will be similar, same, x minus 4, x minus 4. It is always must be similar. Alright, let's solve next part. Now what to do? From these two brackets we have to take any one, x minus 4. One bracket we have to take, and we have to give another bracket, and we have to write the terms written outside the bracket. First x plus 2. Alright, equals 0. Now we shall write either x minus 4 equals 0 or this part x plus 2 equal 0. x equal what? X equal this 0 minus 4 will go to the right hand side, it will be plus 4. Here also x equal this 2 will go to the right hand side, it will be plus 2 will be minus 2. X equal 4 and here x equal minus 2. Now this value of these two are actually the zeros of that polynomials. That means here we can write alpha. We already know. Here you can see these two zeros we can consider as alpha and beta. First one is alpha and second one will be beta. Alright. This is alpha equal 4 and beta will be minus 2. Alright. So here we have find out the first part of the problem, that is finding the zeros. We got the zeros, alpha and beta we already got. So here we solve the first part of the problem, that is finding out the zero. Already we got the zeros, alpha 4 and beta equal minus 2. Two zeros we got. Now you have to verify the relationship between the coefficient and zeros. Coefficient means what? You know, this is the general form of the quadratic polynomial ax square plus bx plus c. And the relation must be ax alpha plus beta, zeros, that means sum of the zeros equal minus b by a. So first consider this is our polynomial, so we can write this. Alright. Verify we can write here. Now the verification we have to do. And the general form we got, that is ax square plus bx plus c. This is the general form of quadratic polynomials, and our polynomial was what? X square minus 2x minus 8. Alright. So our a, value of a means nothing. This is our equation. See in the question. This is our equation. I have written here again for verification. What is the value of a here? Nothing means 1. A equal 1 we know here. We know a equal 1 we can write. B equal minus 2. B equal minus 2 and C equal what? C equal minus 8. Alright. Now we have to find the relationship between the zeros and the coefficient. These are the coefficient. And the relationship means, first of all, alpha plus beta. That means sum of the zeros. Alpha plus beta, you see, this is the formula. Alpha plus beta, sum of the zeros equal minus b by a. And product of the zeros means c by a. These two formula you have to remember. Now alpha plus beta is equal, we know that is minus b by a. Now we can solve this. First of all, we have to put the values. Value of alpha we got what? Left hand side it will be 4 plus value of beta we got minus 2 equal minus, as it is, value of b here we got minus 2, value of a we got 1, four minus 2 equal minus minus plus 2 by 1 means 2. Alright. So here 4 minus 2 is equal to equal, here positive 2 we can write here without giving any symbol. This is positive. Now both side is same. Alright, we got the first relationship. Second relationship we have to verify, that is the product of the zeros. A in alpha into beta equals c by a. This is the formula. Again we can write again alpha into beta, product of the zeros, equal what? That is c by a. Alright. This is the formula, you remember I said again and again. This is alpha plus alpha into beta equals c by a. So value of c here, alpha into beta, first of all we shall put the value of alpha is how much? 4 we got here, into beta, value of beta we got minus 2. Alright. Equal value of c here minus 8, value of a is how much? 1. Alright. Now let us calculate. 4 minus 2 is minus 8, equal minus 8 divided by 1 is minus 8. Left hand side and right hand side came equal. So here we have solved part number 1. Let us solve part number 2. This is part number 2. 4s square minus 4s plus 1. Let us write this. 4s square minus 4s plus 1. Here we can see there is a coefficient other than 1 with s square. That's why we have to multiply coefficient of s square and 1. It will be 4 into 1 equal 4. Now we have to split up this 4 into two parts such that sum or difference of these two parts must be middle term. Alright. We can divide it by 2. 2 to the 4. 2 we can divide again by 2. Here will be 1. That means this two part 2 into 2 equal 4 and 2 plus 2 equal also 4, like middle term. Alright. Now we can write it like this. 4s square as it is minus, in the place of 4 we can write this 2. 2 plus 2, s will be as it is plus 1. 4s square will be as it is minus 2. This minus 2 into one time is multiplied with 2, again another time with 2. Minus 2 into s, minus plus minus, again 2 into s, 2s. Plus 1 will be as it is. One more thing we have to remember, when we are solving this we have to equate it with 0, because we have to find the value of 0. Alright. So 0 will be here. Now this 3 terms becomes 4 terms. We can equally make two part of these 4 terms. In first part 2 terms and second part also 2 terms equally. Now we have to see in this first part which is common. Both the terms we can divide equally by 2s. Alright. So 2s will be common. By 2s we can divide 4s square, answer will be 2s. Minus will be as it is, again 2s we can divide by 2s, answer will be 1. In the next part, which is common? No one is common, means minus 1 we can take here, and this 2s as it is, plus minus 1 divided by 1 will be 1. Here remember one thing, the value of both the bracket must be equal. You can see 2s minus 1, 2s minus 1. Here equal to 0 we have to write. Now from the brackets we have to take one bracket, 2s minus 1, because both the bracket are same, and we have to write another bracket, and inside the bracket we have to write whatever written in outside of the bracket. This 2s minus 1 equals 0. So here we can see both the brackets value are same. We can write here either 2s minus 1 equals 0 or this 2s minus 1 equal 0. Let us solve this. 2s is equal, 1 will go to the right hand side, negative 1 will be positive 1. Here also 2s equal, 1 will go to the right hand side, negative 1 will become positive 1. Now we have to find the value of s. S is equal 1. This 2 will go to the right hand side. It will be, see that, divide. Alright. S is equal 1 by 2. Here we can see we got the value of 2s. And these are actually zeros of this polynomial. And 0 we can consider with alpha and beta. We got two zeros. This is one 0, this is another 0. So we can write first 0 is as alpha equal 1, and second 0 beta, sorry, not 1 by 2. Second 0 also 1 by 2. Now we have to verify the relation between the zeros and the coefficient. Verify. Before verify, we have to write the general form of quadratic polynomial, that is ax square plus bx plus c. In our equation we got, that is what we can write, 4s square minus 4s plus 1. Here we can see this is the a, value of a here 4. This is x square, we can consider s square. Value of b here, this is b minus 4, and value of c 1. We can write here a is equal 4, b is equal minus 4, and c is equal 1. Now we have to verify the relation, that is sum of the zeros. Sum of the zeros means alpha plus beta is equal minus b by a. This is one relation. Sum of the zeros equal b. Here from this b divided by minus, first minus, then this b divided by this a. Alright. Alpha, value of alpha we got here 1 by 2 plus value of beta also we got 1 by 2, equal as it is, minus as it is. Value of b already from this general form of quadratic equation we got, that is value of b is minus 4 and value of a is plus 4. Here we can write both the denominators are same, we can take 1, and when denominators same, then we can write above as it is, all the numbers as it is. Here we can write, you can see minus minus plus 4 by 4. Now 4 cancels 4, answer will be 1. Next, 2, 1 plus 1, 2 divided by 2 equal here 1. In this side also 2 cancels 2, answer will be 1. That means 1 equal 1. This relation is proved already, verified, that sum of the zeros is equal minus b by a. Sum of the zeros also we got 1 and minus b by a value also got 1. Alright. Now we have to verify the second part. Second relation is that product of the zeros will be product of the zeros. Let's see the formula, verification formula. This is product of the zero equal c by a and sum of the zeros minus b by a. Alright. Now alpha into beta equal, what is the formula? C by a. C by a. Value of alpha already we got, that is 1 upon 2 into value of beta also same, 1 upon 2 equal value of c here 1, value of a is 4. Let us calculate. 2 2's are 4, 1 1's are 1 equal here also 1 by 4. In this case also left hand side value 1 by 4, right hand side value 1 by 4. So this is the verification. Here we have solved part number 2. Let us solve part number 3. This is part number 3. 6x square minus 3 minus 7x. Let us write the question first. 6x square minus 3 minus 7x. And we are going to find the zeros of this quadratic polynomial. So we have to equate this expression with 0 to make it equation. Alright. Now we can see here this quadratic polynomial is not written in standard form. We have to write it in standard form. Standard form means first we have to write the variables with highest power 6x square, then the variable with less power, that is 7x. You see variables with variables, and the constant will be the right hand side. Alright, equal 0. Now we can solve it like earlier by splitting the middle terms, that is in prime factorization method. First of all we have to multiply 6 into 3 equal 18. Now we shall find the prime factors of 18. We can divide it by 2, 2 9 is 18. Now we can see here 9 minus 2 equals 7. We have to split up this number such a way sum or difference of these two factors must be middle terms. Alright. So 9 minus 2 equals 7, and 9 into 2, that is 18. Now we can write this 6x square minus, in place of 7 now we can write 9 minus 2, x will be as it is, minus 3 will be as it is, equal 0. Now 6x square minus this minus and 9 multiplied, minus 9, with that we have to multiply x, because x is one time multiplied with 9, again x is one time multiplied with 2. So minus 9 into x, minus 9x, minus minus plus 2 into x, 2x, minus 3 equals 0. Now we got here 4 terms, and these 4 terms we shall divide into 2 equal parts. Alright. So in first part, which factor is common? That is, both the terms we can divide by which of the factors. 6x square 9x. First of all, both we can divide by 3. That's the numerical value 3. Then 3 is common, and both the variable we can divide by x. So 3x is common. Now by 3x we have to divide 6x square. We can get here 2x, minus by 3x we have to divide 9x, it will be 3, plus here we can divide, there are no any common number here or common factor here, so we can take care of 1 and plus 1 because positive sign is here. Now when we took the common 1, then whatever outside, everything will be same. 2x minus 3 equals 0. Remember one thing I said so many times, that we shall get here 2 brackets, and both the brackets will be same. You see value of the brackets 2x minus 3, 2x minus 3. From here we can take 1 only. We shall take 1 bracket 2x minus 3 into, we have to take another bracket, and inside the bracket we shall write whatever factors written in outside of the bracket, that is 3x plus this 1 equal 0. We have to find the 0 now. Either this 2x minus 3 equals 0, or this 3x plus 1 equals 0. 2x equal plus 3, 3x equal minus 1. Now scroll it up. X is equal 3 by 2. Here x is equal minus 1 by 3. Here we got the two zeros of this polynomial, that is 3 by 2 and minus 1 by 3. 2 zeros means we can consider, that is 1 is alpha equal 3 by 2, and another 0, that is beta equal minus 1 by 3. Now we have to verify the relation between 0 and the coefficient. Verify. Before verify, you have to write the general form of quadratic polynomial, that is ax square minus bx minus c. Here we shall write our equation, which is given in this form, that is 6x square minus 7x, that we arranged in this form, and the value of c was 3. Here value of a, this is a equals 6, value of b minus 7, and value of c equal minus 3. Now we have to verify the relationship between zeros and the coefficient. The relation is that first relation, sum of the zeros, that means alpha plus beta equal minus b by a. We shall put the value of alpha first, 3 by 2 plus value of beta minus 1 by 3 equal minus, as it is, value of b is minus 7 divided by value of a equal 6. We shall put bracket here. We have to take the LCM of the denominators. 3 to the 6 by 2 we have to divide 6, it will be 3, 3 is a 9, plus minus minus by 3 we have to divide 6, 2, 2 1 the 2 equal minus minus plus 7 divided by 6. Here 9 minus 2 equals 7 divided by 6 as it is equal 7 by 6 as it is. So here we have verified the first relation, that is alpha plus beta equal minus b by a. Now we have to verify the second relation, that is alpha into beta equal, what is the relation, that is c by a. Value of alpha 3 by 2 into value of beta minus 1 by 3 equal, now value of c equal minus 3 and value of a equal 6. 3 into minus 1 equal minus 3, 2 into 3 equals 6 equal minus 3 by 6. So here both the side we got equal, left hand side and right hand side equal. Hence it is verified. Verified. This is the answer. So here we have solved part number 3. Let's solve part number 4. This is part number 4. 4u square plus 8u. Let us write this question first. 4u square plus 8u, and we have to equate it with 0. Then we can find the value of zeros. Alright. You can see here in this expression only two terms are given. C is not given. Ax square plus bx given, c not given. We shall solve it little different way. In the both the terms, which is common? 4 is common and u is common. So we can take common 4u. 4u divides 4u, answer will be u only, plus by 4u when we shall divide 8u, u cancels u and 4 cancels 8 gives 2 equals 0. Here we can write either 4u equals 0 or this inside the bracket u plus 2 equal 0. U equal 0 by 4. That means u equal 0. Here u equal 0 minus 2. That means u equal minus 2. Alright. So here we found the value of zeros of this polynomial. One is 0, another is minus 2. The first 0 we can consider as alpha equals 0, and the second 0, that is beta equal minus 2. Now we have to verify. Before verify, we have to write the general form of quadratic polynomials, that is a x square plus bx plus c, and our polynomial is 4u square plus 8u, and value of c, this ax square bx, ax square plus bx, and value of c we can consider here 0, because in our equation up to 8u is given. All right, so c in the place of c we can write 0. Here a equal coefficient of x square is a 4, and b means coefficient of u, this is u square actually, and this is u. Coefficient of u is 8, that is value of b is 8, c value of b, and value of c equal 0. First relation, that is alpha plus beta equal minus b by a. Let us prove this or verify this. Value of alpha is 0. You can see here value of alpha 0 plus as it is value of beta minus 2 equal minus as it is value of b is 8 divided by value of a is this one 4. 0 minus 2, 4 cancels 8 by 2 minus 2. Here 0 minus 2 means minus 2 equal minus 2. So we got both the answers similar or equal, left hand side and right hand side. Here first relation is verified. Now second relation, that is alpha into beta equal c by a. Alpha, value of alpha we got 0 into value of beta we got minus 2 equal value of c we got 0 and value of a we got 4 here. 0 into minus 2 is 0 only. We know that this is one of the property. When any number is multiplied with 0, the answer always will be 0. Now 0 is divided by 4. Here also quotient will come 0. Both left hand side and right hand side came 0. Here we can say both the relation is verified, that alpha plus beta means sum of the zeros equal minus b by a, both equal, and alpha into beta, that means product of the zeros, is equal c by a, minus 0 and 0. Here hence verified. Hence verified. With this, part number 4 completed. Now we shall solve part number 5. This is part number 5, t square minus 15. Let us write the expression first. T square minus 15, and we have to equate it with 0. You can see here only two terms is given, middle terms is not here. So we shall solve it in different way a little bit. T square is equal, 15 will go to the right hand side, minus 15 will be plus 15, and of course 15 plus 0 is 15. Now we have to remove this square. For that we have to give one root over symbol, then square cancels root over. Both side this root over symbol we have to put here, square cancels root over. Now t is equal under root 15. And one more thing, while we are writing under root, we have to put a plus minus symbol in front of that. Plus minus. Alright. It means t equal 1 time plus 15 plus root over 15, again t equal minus root over 15. This means plus minus. Alright. So we got here value of zeros of this polynomial. One is here 15. Plus under root 15, another is minus under root 15. We can write alpha is here plus under root 15 and beta equal minus under root 15. So here we got the zeros of the polynomial. Now we have to find the relationship between zeros and the coefficients. So we shall write verification verify. Before verifying, we have to write the general form of quadratic equation, that is ax square plus bx plus c. Here what is our quadratic equation? That is t square minus 15. Here a, the variable with square, coefficient of t square is nothing, means 1. So we can write here a is equal 1, b nothing, because here middle term is absent. So we can write here b equals 0. And c equal, we can write here minus 15. Now the first relation, that is sum of the zeros, alpha plus beta equal minus b by a. Value of alpha is under root 15 plus value of beta minus under root 15 equal minus, as it is, value of b we got here 0 and value of a 1. Under root 15 plus minus minus under root 15 equal 0 minus 0 divided by 1 is 0, and 0 has no negative. Finally we can get here under root 15 minus under root 15 is 0, equal, here also we got 0. So both the sides, left hand side and right hand side, we got equal, as it is verified that sum of the zeros is equal minus b by a. Alright, now we have to verify the second relation, that is product of the zeros, alpha into beta equal c by a. Similarly, we have to write the value of alpha, that is positive under root 15 into negative under root 15 equal value of c is value of c minus 15, value of a 1. Here we can write minus plus minus minus 15 root under root 15 into under root 15, we can write under root 15 square equal, here we can write minus 15. So here we can see square cancels, root over minus 15 will be the answer, equal minus 15. So here also both left hand side and right hand side equal. That means this is verified. So here part number 5 is completed. Let's solve part number 6. This is part number 6. 3x square minus x minus 4. Let's write this question first. 3x square minus x minus 4. We have to write equal 0. Now multiply the coefficient of the first term and the last term, that is 3 into 4 equal 12. Now we have to factorize this 12. 3, 4. Now remember, here it is x, middle term is x, means 1x. So we have to split up such a way 4 minus 3 is equal 1 and 4 into 3 equal 12. Alright. So we can write here 3x square, as it is minus 1x in place of 1. Here there is a 1. We can write in place of 1, we can write 4 minus 3. Alright, 4 minus 3 x, as it is minus 4 equal 0. 3x square minus 4 into x minus 4x minus into minus plus 3 into x, 3x minus 4 equal 0. Now here we can see we have got 4 terms, and we shall equally make two parts like this. In first part, let us check which number is common. We can see here in both the terms only x is common. X is common, then we can write here 3x minus, by x we have to divide this, answer will be 4, plus in second term which is common in both the terms, no one, so we have to write 1, then 3x minus 4 will be as it is equal 0, and we know that the value of both the bracket will be same, 3x minus 4, 3x minus 4, we shall take any one from them. 3x minus 4 into, we shall write another bracket, and inside the bracket we shall write whatever left outside the bracket, x plus this 1 equal 0. Now we can write either, we have to find the value of zeros now, either this first bracket, that is 3x minus 4 equals 0, or the second bracket x plus 1 equal 0. 3x equal 4 will go to the right hand side, it will be positive 4, equal this x will be left hand side, 1 will go to the right hand side, positive 1 will become negative 1. Here x is equal 4, 3 will go to the right hand side, it was multiply, it will be divide. Here x is already, we got minus 1. We have got the values of zeros, 2 zeros we got here. First one is 3, so first 0 we can consider as alpha equal 4 by 3, and second 0, that is beta, equal minus 1. Alright, now we have to verify. Before verify, we have to write the general form of quadratic polynomial, that is ax square plus bx plus c. This is the general form of quadratic polynomial, and our quadratic polynomial, whatever we have got in the question number 6, that is 3x square minus x minus 4. Now compare this with this. In our quadratic polynomial, what is the value of a? That means a, here a is 3. Alright, we can write here a equal 3, b equal, in place of b here nothing means 1, so b equal 1, and c equal, here c equal minus 4. Now we have to verify the first relation, that is alpha plus beta equal minus b by a. Let's verify this. Value of alpha is what? We got here 4 by 3 plus value of beta we got here minus 1 equal minus, as it is, value of b is 1, I think minus 1, yes, here will be a minus because minus 1 is here, minus 1 divided by value of a is 3. Let us calculate this. Here nothing means 1 is there. 4 by 3 plus into minus, minus 1 by 1 equal minus into minus plus 1 by 3. 3 and 1's LCM will be 3. By 3 we have to divide 3. Answer will be 1. 1 into 4 equal 4. Minus 1 into 3 will be 3 into 1, 3 equal 1 by 3. 4 minus 3 equal 1 upon 3 equal right hand side also 1 upon 3. So you can see here the verification is correct. We have already verified that alpha plus beta equal minus b by a. Value of this part is 1 by 3 and value of this part also 1 by 3. So here we have verified the first relation. Now let us verify the second relation, that is alpha into beta equal, we know that C by A. Let's write the value properly like earlier. Value of alpha we got how much here, that is 4 by 3 into value of beta minus 1 equal value of C we got minus 4 into value of A we got 3. 4 into minus 1 will be minus 4 divided by 3 equal right hand side already minus 4 by 3. Here also we got the similar value left hand side and right hand side in case of product of the zeros equal C by A. Alright. With this all the parts of question number 1 is completed. Let's meet again in the next video. To get all the classes regularly, please subscribe my channel. We shall meet again in the next video. Till then, thank you very much.